Okay. Started recording. IP addresses. Guys, remember one thing. We are all using a star topology. Star topology. Remember. We are all using star topology. Okay. Generally, in any LAN network, it is a star topology only we are using. We are not using ring topology, mesh topology, bus topology. We are not using. We are using star topology or extended star topologies only. Okay. The next one is our protocol suite is TCP/IP protocol suite only we are using. We are all communicating with the protocol suite is TCP/IP protocol suite, not IPX, SPX or anything. We don't use it. And we are all using IP addresses. What we are using. Okay. Okay. We are using IP addresses only, not other logical addressing, not other logical addressing like IPX, SPX kind of addressing or Apple Talk kind of stuff, protocol suites or addressing. We don't use. We use only IP addresses. In that IP address, we have IPv4 and IPv6. And mainly IPv4 is a main IP addressing is based on IPv4 only. IPv6 is still not globally distributed. 100% IPv6 we are not using. We are using mainly IPv4, not completely IPv6. Okay. So because still there is a lot of organizations, servers, routers, and in publicly and privately, not completely IPv6 compatible. That's why still we are using IPv4. And of course, we'll discuss IPv4, IPv6 things also. Okay. This is our remember this point. Okay. In broadband internet, we use a PAT technology, port address translation, not NAT technology. We are using port address translation in our home. Small office, home office kind of stuff. Broadband internet is based on the PAT technologies. Okay. These are the terminologies PPP, OE kind of stuff we are using for getting internet. Point-to-point over Ethernet we are using. Okay, broadband internet is point-to-point over Ethernet. Okay, and IP address translation. For IP address translation, we are using PAT, not NAT. Okay. Of course, we are using a Wi-Fi routers for getting connected, both wired and wireless. Of course, we are using. For home Wi-Fi routers act like a modem. It is a modem plus router plus wireless access point for a wireless device connectivity. Of course, there is a built-in hub or a switch part is there. Okay, it is a one for everything. Next, this same wireless Wi-Fi router for us, it is a DHCP server and it is also a local DNS server. It is our local DNS server and our default gateway also. This is the same device. Okay, so one Wi-Fi router is act like a modem to connect internet, router to route the packets from inside to outside, right? By connecting internal network to additional network. And also we are using Wi-Fi router means it is also a wireless access point to connect a wireless devices. And also router having a backside the LAN port connections are there. So like a for wide connectivity is also there. Okay. So next one is this same Wi-Fi router is act like a DHCP server because when you connected to your Wi-Fi router, when you are connected to your Wi-Fi router, you are getting an IP address. Means who is giving IP address? Wi-Fi router. So Wi-Fi router giving you an IP address means it is act like a DHCP server. Okay. So if you look at your IP address, your DHCP server IP address, your DNS server IP address, your default gateway IP address is same. Means all these things are by your Wi-Fi router only. Okay. So your local DNS server is also Wi-Fi router. For example, I open a web page like this. I open a web page. I don't know IP address of this particular www.w3schools.com or studio.youtube.com or docs.google.com. I don't know the IP address. Who will give IP address? To whom I am asking? My local DNS server. I will ask. I need a IP address of docs.google.com. Okay. Who is my DNS server now? My Wi-Fi router. So my Wi-Fi router returns an IP address of docs.google.com. Okay. It is act like a local DNS server. Okay. Default gateway. I am in the network. I am in my own LAN network, but I want to communicate outside of network like facebook.com, youtube.com. These are all we are communicating. So to communicate outside of our network, which way we will go? So how we know? Based on the default gateway configuration. Who is our default gateway configuration? Is our Wi-Fi router only. Okay. So like this Wi-Fi router will do all functions in our home. Not exactly Wi-Fi router does not mean these things, but our home Wi-Fi router is act like these many features inside, including firewall, DDoS, DDDNS is there, or firewall is there inside. Firewall also we can build. Okay, VPN connectivity we can do it. Okay, dynamic DNS kind of stuff also we can do it. Okay, of course you can configure firewall also ACL part, but not exactly. We are not using that one, so that's why I'm not written that one. Okay, guys, the topic today is actually IP address. IP address. So first of all, about IP address, you already know it is a logical address. MAC address is, and I'm telling,
Physical address.
very good. MAC address is a physical address. It is changeable either by a user or maybe or by DHCP server. IP address can be changeable. MAC address it cannot change and change the MAC address. That is okay. It is assigned by manually or automatically, means by DHCP server. This is assigned by manufacturer. I see. 9 facts of that NIC. Next, we have two versions, IPv4 and IPv6. Two versions are there. Here it is no versions. So IPv4 is 32-bit, and whereas IPv6 two versions are there, 128-bit. But this is only 48-bit. It is a 48-bit represented in 12 hexadecimal. Represented in 12 hexadecimal. So point is, all communications by IP address only. So you cannot communicate with a name or a MAC address. We use MAC address in some places. That's it. Okay. If you want to add some more points, also you can add it. So again, guys, IP address is a logical address. Logical. IP address is a logical address. Okay. Every device in network need IP address to communicate in network. Okay, every device must have an IP address to communicate. Okay, without IP address we can't communicate. So generally I will draw some kind of stuff like this. Like this I will draw. Uniquely identify a device in network. What is an IP address? You can identify IP address, to identify a device in the network is called uniquely IP address. It is not unique address. Okay, so do not say IP address is unique address. Unique address is MAC address again. Hardware address, physical address, unique address are a MAC address. Once a MAC address is there, so it is not repeatable. Okay, it is not repeatable. In IP address we have a private and a public IP address is also there. They are not applicable that point. Okay. So I said I will draw something, but it will kills the time. That's a problem. Very good. So I have a devices like this.
Hello, sir.
Yeah, tell me.
Sir, how do we distinguish like a public or private IP address?
Depends upon a IP address. If it is in the private range, the range is there, private IP address range is there. If your IP address is in the private IP address range, it is a private IP. If your IP address is not in a private IP address range, it is a public IP.
Okay, sir.
Okay, good. Example PCA. So I am giving some IP address. Why I am giving 10 series? Because it is a small in size as compared to other IP address generally available. Okay. So if you observe, each IP address is look like a same, but the last number is changing. Only if you are observe, I put a only last number is changing. So I can change other numbers, but to avoid a confusion, that's I put a only last number is. This can be a switcher hub, that is your wish, how you put it. So point is, PCs are there in the network and they are communicating each other because of they have an IP address. For example, from PCA or at PCA, at PCA, PCA to PCB communication. So how you communicate like a ping request. So at PCA you have to ping PCB IP address like this. Okay. So we'll do like that. From PCA at in a command prompt. In command prompt, you put a command. So PCB IP address. Okay, like this. This is how we can communicate. This is called a unicast communication. Means we are sending a message to only one PC at a time. So that is called a unicast IP communication. Next, yeah. I will tell one example before I can tell later also, but I will tell now one thing, guys. So why it is that last number changing? Why this is P IP address? We call it as a logical address also. Your batch is 12th batch, right? So I'm giving a roll numbers to you like a 1201, 1202, 1203, 1204, 1205, 1210, 1224, 1232. What is this meaning? It is a belongs to 12th batch, first roll number, second roll number, third one, fifth one, 10th one, 24th one, 32. But what is the common one? The common one is the 12. So this is belongs to entirely 12th batch only. Morning I have a 11th batch, so like 1101, so 1102, 1112, 1115, 1120, 1132, 1144. What is this? The 11th batch and their roll number, individual identity. Individual identity. So the IP address is also similarly. This, there is a one network identification and there is a host identification. Okay. So like each and every person having a roll number along with the batch number. Apartment, floors, numbers, similarly like 404, 405. For example, I will write here the 1201, 1204, 1205, 11, 15, 11, 12, 13, 10, like this. If you look at here, these are not belongs to same batches. How can I identify? Because of I put a rule, this indicates, these two positions indicates batch number. So this is belongs to one batch, this is 2 or belongs to another batch, this is belongs to different batch. Okay. So because of this kind of logical division, we have a logical addressing. Okay, this is also very useful for understanding network and host manner. In this one, I have taken the 11, 12, 13, 14 that indicates that the host numbers. Remaining become a network like that. Okay. Of course, there is a lot of things are there. So we'll see that one once we are going to the classes of IP address. Guys understand?
Yes, sir.
I'll give you a small difference between IPv4 and IPv6. Lot of differences are there, only small differences I will try to give you. Guys, IPv4 is 32-bit, IPv6 is 128-bit in size. 2 to the power of 32 is around 4.3 billion IP addresses. You will get it. If you want to calculate, you can go to calc. There you can find it. Okay, this is the size, the original size. If you take 2 to the power of total IPv6 addresses are 3.4 into 10 to the power of, okay, 3.4 into billion, billion, billion. I don't know the trillion part, so that's why I given billion, billion wise. It's a 3.4 into 10 to the power of 38 means after 34. So you have to write first 34. First 34 you have to write. Then you have to keep zeros. 37 zeros you have to put it. So like this I will put it 37 zeros means 1, 2, 3, 4, 5, 6, 7. 7 completed. Next 30 zeros you have to put it. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now 10 plus 10, 20 completed. 5. So if you want to count correctly, you have to open the Sanskrit textbook. Okay. So this is the total size of your IPv6 address. You want to calculate. So 2 to the power of 128. So 3.4 into the very big number. Easiest way is 10 to the power of 38. Okay. That is the length of this IP address. So IPv4 has a very limited IP addresses because it's 4.3 billion IP addresses. Nowadays, in the worldwide, number of devices are increases, number of servers are increases, number of public IP address requirement increases. So then it is not enough IP addresses currently. Okay. IPv6 is a remedy for IPv4. It is the next version of IPv4. It is the next version of IPv4. Okay, it will give billions of IP addresses. In future, maybe we are all using IPv6. So there is now maybe for next 50 years, this IPv6 addresses are more than enough. Okay, currently in a worldwide, we are using a 1 by 8 part of IPv6 only. We are released into the public. Okay, so in 1 by 8%, but okay, we are using very less than that one. Now, example of IPv4, how it is look like it is 192.168.1.100. This is how IPv6 is look like, and here it is. This is in a hexadecimal format. Example is very bigger, so I am going to. This is little, 8 blocks completed, 8 more blocks.
Hello, sir.
Yeah, tell me.
Actually, I saw on the internet that when we search what is my IP address on web browser, it shows the IP address.
Very good.
So is that was the correct one? Because when I checked with my IP address on a system configuration, that is a different from that.
That's a good thing you tried. Okay, so whenever you try, when you check your IP address on your web browser, so your Google is returning your IP address, right? So that is your public IP address. If you read, your public IP address is, right, that is your public IP. But when you go to the how to check IP address like IP config command, that is your PC private IP address in your LAN network, your private IP address. Okay.
Okay, got it. Thank you.
So Rehan told 340 undecillion. Okay, that is a 340 undecillion. That is the one. Okay. So we need totally 8 blocks like this. So this is the 4 blocks completed. This is another 4 blocks. So yeah, it is. This is how it is look like, guys. Some people call it as alphanumeric. No, it is hexadecimal format. Hexadecimal format combination of A's and B's is there. It is like a 0 to F number. Okay, if you want to know what is hexadecimal numbers, already I given a table here. Okay, see this is the binary decimal numbers 0 to 9. As a single digit 0 to 9 is a decimal number. As a single digit in binary 0 or 1. Hexadecimal start with a 0, end with F as a single digit number. Octal, so 0 to 7. Okay, it is a 0 to 7. So hexadecimal numbers. What I am opening, yeah, this is the thing. Okay. IPv4 actually represented in a decimal numbers. Is represented in hexadecimal. Hexadecimal numbers. Okay, of course, this is basic points. Okay, hexadecimal format and decimal format. So format is a better word. Okay, so this is, I will go to IPv6 before that one. So I am telling you about IPv4, guys, concentrate. It is a 32-bit. Can you see this is a IPv4? It is a 4 parts are there, 192 one part, 168 one part, 1 and 100. It is separated by dot. Okay, so this 32-bit is divided by 4 parts and separated by dot. How to spell it? 192 dot 168 dot 1 dot 100. Okay, this 32-bit is divided into 4 parts and separated by dot. Okay, so 32 by 4 means 8 bits. This 8-bit we call it as an octet. The 8-bit is called as a one octet. Okay, so an octet means how many bits? 8 bits. So 2 to the power of 8 is 256. 256. Meaning is it's 0 to 255. Each octet size is 0 to 255. Each octet size is 0 to 255. So how many octets are there? 4 octets. We have a 4 octets. So how these 4 octets are there in IPv4? 0 to 255. So each octet size is maximum, 255 is highest. Four octets. The first octet is called a first octet. Okay, the octets are having names. Okay, first octet, the second octet, and the third octet, and fourth octet. These are the octets.
Sir, 8-bit is equal to 1 octet.
Yes, 8-bit. The size 8-bit now, so that's why we call it as a octet.
Okay, sir.
Forest it is. My mouth is got it's okay. Sorry. Okay, these octets. Some people, for some people, make it more easier, they will put a certain symbols like W, X, Y, Z. Okay, so it depends upon a person to person is there. Okay, generally to make it easy, some textbooks also will give instead of telling first octet, second octet, third octet because the word is bigger. Okay, so then W, X, Y, Z as per the placements. The W term or X term or Y term or Z term, we can use it like that. Okay, but each octet size is from 0, 1, 2, 3 up to 255, not more than 255. For example, you have an IP address 100.255.10.23.230. So it is valid IP address. For example, I have an IP address 1.2. Okay, 257. Okay, 2. This invalid IP address because of 254. It is a bigger than 255. Here it is, all octets are below 255, either 0 or a 255. It is good, it is not good. Okay. So this is about your IPv4 continuation. So yeah, so one more points are there, some more points are there. This is the starting IP address and this is the ending IP address. This is the last IP address. You know how it starts. This is the starting. The next IP address is like this. Next IP address is like this. It keep on going on like up to 254. This is a 255 is the last IP address in this particular series. You know, next one become like this. Like, you know, 99. Next one is 100. 199. Next one is 200. 999. Next one is 1000. 1999. Next one is 2000. Right? 4 nines. Next one is 10,000. Similarly, it is also goes like this. 101. Goes like this. 0.0.1.254. 0.0.1.255. Last. 0.0.2.0. 0.0.255.255. You reach like that. 2.0, 2.1, 2.0, 2.1. Okay, so 255. So finally, right, there is a always put a 1 0.0.255.254 0.0. No, 0.255.255. It is like a follow, like a sequence. 0.1 dot 0.0, 0.1 dot 0.1, 0.1 dot 0 dot, so 255, 0.1 dot 1 dot 0. Okay, again 0 dot, so like that it will keep going on. So 1 dot 1 dot 1, 0 dot 255 dot 255 dot 255, 1 dot 0 dot 0 dot 0, 1 dot 0 dot 0 dot 1. Again it keep goes, it will reaches like this. The last one. Just I want to tell there is a so many variation. If you write from here to here, you have to write at least 4.3 billion times. These many times you have to write. Each one you have to write. So you have to write like this. From here, like this, like this, like this, you have to write. So I don't know how many pages are required to write. Okay. So this is the IPv4 range. Starting is 0.0.0. The last one is 255.255.255. Okay. In IPv4, we have a 0.0.0. It is, we don't use it. This is called it is a reserved IP. We don't use it. In IPv6, it is a colon. So few differences are there. And yeah, so remove it and leave it. I will tell later that is. Guys, IPv4 addresses, IPv4 divided addresses divided into 5 classes. Okay, so those classes are class A, class B, class C, class D, class E. Okay, actually there is a binary thing is there, so we'll see. To identify a IP address means which class is the first octet or W part. Okay, so I will give you that one. So, you know, the first octet means how many bits? 8 bits. So starting with a 000. Anyway, starting with a 000. Okay, the first bit, because class A is the first one, the first bit will be same, so no changes. It takes same as remaining become ones. Okay, now the value of this one is 0 to 127. In binary it is in decimal 0 to 127. In some textbooks we'll write in different way, like this 1 to 126 or a 0 to 126. Okay, or a 1 to 127. There is a reason behind it. I will tell that reason. Yeah, I will tell once I completed this table. Okay, normally. So this is the next number of this one. This is the next number of this one. So it is a class B. So first two, because second one having first two are same, so no changes. This is the same. Remaining become ones. It is a range. So how the range is created, like that, 128 to 191. That is a binary equivalence. So here it is class C. First three are same. So first three we don't touch. So remaining becomes zeros become ones. It is a 192 to 223. What to do, guys? Take it, read it multiple times. Okay, if you cannot remember, by heart it. I don't mind about it. Okay, so people said no by hearting. Guys, without by hearting, you may not pass even first class also, second class, third class also. No, so since we are doing since childhood days, we are reading. By hearting does not mean any other thing. It is just we are reading, and we are trying to remember things as directly. Okay, so later logical application, if you are remember, then you can apply your logical part to get inside. Okay, so this is the next number, class D, 111. Remaining are zeros. So here it is. D is the fourth one. So first 4 bits are same, no changes. Remaining become ones. So 224 to 239. The value is 239. This is 4 ones, 4 zeros, and it is all are ones because it's the last one. No change. It is all are ones only. So it's a 242, 255. Okay. So this is the class ranges. I said no. There is a reason behind this one. So I will tell like this. Okay. We cannot assign to NIC. So we cannot assign some IP addresses to NICs. So who are that one? 0.0.0.0, because it is a reserved IP address, also called as a unknown used in a certain services. Used in a certain services. Next one, this entire zero series we don't use it. This entire zero series we don't use it. Next one is 127.0.0.1. This is also a reserved IP address for loopback or local host IP address. Like dhcp kind of stuff. What is this loopback or local host? Yeah, we have a diagram this one, so we have to copy this. Can we take this one separately? Can take it. Very good. Guys, every PC has their own IP address, right? In this case, okay. But I am every PC, they are having their own name called a local host. Every PC has their own name and every PC has their own IP address is there. Okay. So every PC uniquely we are having a names. Every PC having their IP address for communicating each other. But every PC itself having their own name and one IP address is also there. Okay. So for example, we don't get anything here. PCA ping to itself. How it is ping? Ping to 127.0.0.1. For example, PCA ping to PCB. Same example. How to ping? So 10.0.0.12. To communicate other devices. To communicate other devices, we use other device IP address. But when you are trying to communicate yourself, that is your loopback ID. It is used for a testing purpose. It is actually for a testing purpose. I will give you one simple thing. Guys, this is my S server is there. Usually I will try the LAMP servers or web server kind of stuff, Jenkins servers kind of stuff. Okay. So this is having a service like maybe a database service. Okay, it can be a Oracle database service, MySQL service server. Okay, I install a MySQL application, then it is a database server. Or Oracle database I install, then it is a database server. Maybe I install a Apache HTTPD or Apache Tomcat. So what happened? I install an application in this PC and I want to access from this PC. Means server is here, client application is also here, same PC. To how I access, I use IP address, loopback or localhost address as like this 127.0.0.1 to communicate inside within the PC. For example, I have another PC, it's a client PC. I want to access this application. I have a client application in this particular PC, separate PC. What to do? I have to access through this PC IP address. For example, this is 192.168.1.111. So what I will do? 192.168.1.11 only. I should not use 127 here. If I use 127 here, what will happen? I will connect it to myself only. If I use like this, I'm connected to this server. That's the difference, guys. It is a loopback or a localhost IP address. It is a itself type, and also what is this testing part? Also, I will try to show you this. If I'm pinging to my localhost means myself. Like my name is Latif, right? So if someone want to call me, they will call with my name, right? Latif, right? But if I am calling myself, how I call myself only. Okay. For me, I don't need my name. For someone to call me, I need a name, right? Name is meaning is what is a name for calling by someone, for just for identification in public, right? So for yourself, you don't require any name, right? That is called a localhost. It's self type. I'm pinging to my localhost, but there is a two things are there. If I want to communicate to a device with IPv4 protocol, then use -4. See it is, I am getting a 127.0.0.1. But same localhost IP address also there for IPv6. This is IPv6 address. Okay. So I am communicating, I am pinging to my PC only. I am not pinging to anyone. That is a ping test. It meaning is your TCP IP in your PC is working fine. Okay. So network functionality is good, working. Thus networking related TCP IP service is working fine. Usually self-testing purpose. Okay. And there is a point here. It is : 1 in IPv6. This is also same thing. This : in IPv6. And also we don't use 127 series. Entire series is banned. Okay, because of loopbacks. So it is also reserved for loopbacks. We don't use things. Don't use this different, guys. We cannot assign to any adapter. If you have an NIC, you want to assign this IP address, it won't agree. Okay, these are the IPv4 classes. And of course, small points also there. This is also we don't use it. This is people say it is R&D. So certain places or certain research are reserved IP addresses. This is a multicast. We cannot assign. This is also we cannot assign to any adapter. Multicast IP addresses. Class B. Multicast IP addresses also we cannot assign. We use it in a certain services. Okay, we cannot assign to NIC. That's it. So this class A, class B, class C are a unicast IP address. Class A, class B, class C are unicast IP address. One more series is there, guys. 169.254. This entire series is a API, automatic private IP address. Okay. The IPv6 we didn't touch again. So, but in IPv6 also we have a different kind of stuff is there. So there is a global unicast IP address. Private IP address is also there. Link local IP address is there. This link local, every PC has IPv6 enabled PCs. Link local IP address is there. If you want to check it, I will show you IP config. See, my PC also having a link local IPv6 address. Okay, my PC itself having a link local IP address. Okay, so every PC having a link local IP address. It works in a LAN communication. You don't require any DHCP DNS. Sorry, you don't require any DHCP to assign an IP address. By default, it will generate. Generated by system based on MAC address. MAC is enough. It is generated by system. So this is like a public IP address. Okay. It is like a public IP address by ISP. Okay, it is given by ISP. Okay, different IP address is there, guys. So that is the point. Of course, IPv4 having a multicast is also there. Multicast IP address is also there. Private IP address, multicast IP address, unicast IP address. Unicast, global unicast, private unicast, multicast, link local kind of stuff. And IPv6 also having any cast IP address. Okay. You have a broadcast, but there are having a any cast. IPv4 having broadcast, but IPv6 having any cast. Okay. Maybe MAC address is intercast. Okay. This is about basic points in IPv4 and IPv6 and IPv4 and MAC address. Okay. So next part is about IP address and subnet mask. Okay, about IP address and subnet mask and private IP address, NAT/PAT kind of stuff I will tell. Okay. You guys understand up to now?
Yes, sir.
Yes, sir.
Now take a break because it's already have started